Assalamualaikum. I'm from Group 1 and I will explain the solution of our case study, which the automated bottle filling system using the PLC. So we meet with the group member, which consists of Muhammad Hazim, Huda Natasha, and also Muhammad Nabil Fikri. So we move to the introduction, which the bottle is filled using the industrial automation and also a PLC. So the user may choose how much liquid or water they want to put in the bottle. Besides that, the method to fill the bottle, we can use a ladder language such as CX Programmer as a simulation of our project. So next, the filling is carried out by utilizing a motor, the actuator, sensor, conveyor belt, PLC, and the other tools. So moreover, PLC has been used for input and output control. It is primary functional units of automation system. So the last part of the introduction is the filling procedure is being used. So the combination of electronic, computer and mechanical component are all the part of discipline of engineering. So we move to the literature review part, and I will explain the literature review part. In this section, there has 4 previous projects that related with our proposed system project. Firstly, the automatic bottle filling system using PLC based controller. So the conveyor will start to move when the button of power supply is turned on. So after the system or the supply is turned on, the infrared sensor will detect the bottle at some point, and it will stop the conveyor, and the DC pump will start to flow the water, start to fill the water until full. Then after complete, the DC pump will turn off and the conveyor will start to move to the other section. For the finding, we can say in 3 seconds, it can fill a 200 milliliter bottle. So it has a fill rate which 67 milliliter per second, and operate with a timer. For the second project, which the automatic bottle filling system using PLC. So initially, when the conveyor is turned on, or when the button is turned on, so there has 2 or 3 bottle will put on the conveyor, and it will move until photoelectric sensor sense the bottle. When it sense the bottle, the conveyor become up or stop. Then the solenoid valve will turn on or open in order to allow liquid or water to fill up the bottle, until the predetermined amount. So when the predetermined amount is time up, the solenoid valve will end. The solenoid valve will close, and the conveyor belt will start to move again, and the operation is same when come to the second or third bottle. So for the finding for this literature review, so when the auto start push button is pressed, the motor start and the conveyor belt begins to move. Third of the literature review is automatic bottle filling and capping system using PLC. So they consist of the conveyor belt and 2 rollers were installed. The primary structure where the bottle is filled and moved via the guider. The component is equipped with the conveyor, which is positioned after the capper to direct the bottle cap and filter to their ultimate position. So the cap dispensers duty is to thoroughly remove the cap from the top of each bottle as it passes. So there is motorized capper and a pneumatic cylinder in the capper component. Its task is to rotate the cap into place on top of the bottle and seal it. For the finding, the times for the bottle filling is 30 seconds, while the rotation angle for the cap dispensing is 90 degree. Rotation angle for cap fitting from start is 180 degree, while the stroke length is 55 millimeter, while the software structure is using programmable ladder logic. So for the last part of literature review is the project automatic bottle filling system using PLC, which the method is to detect the bottle and the liquid will dispense in the required quantity and the bottle will move along the conveyor belt. For the finding, it is suitable to use in robotic processing, while the procedure is improved by using it. Numerous applications in the industry are made available by PLC, and lastly, the various of handling levels are integrated using it. And we will move to the methodology part. I will explain the third part, which methodology. So in this methodology, there has two sections to be explained, which flowchart and component proposed to use. Firstly, in flowchart, the flowchart is constructed in order to show the sequence of operation of the bottling line automation using the PLC. So the operation will start with the push button is pressed. When the push button is pressed, DC motor will start rotate and move the conveyor belt in the low speed. So after that, it moves to the first section to fill up the bottle. So when reach the first point, proximity sensor, which photoelectric sensor, detect the bottle. And after that, the conveyor will stop for a while, and then photoelectric sensor again we will detect the surface of the bottling, either the size is small, medium or large bottle. So when the bottle size is determined, the solenoid valve will open and fill up the bottle until full. So each of the size of bottle have a different delay of the filling process. So after that, when the bottle is completely full, so the motor will start back and move the conveyor to the next section. Next, we will move to the second section, which components proposed in this project. So the components that proposed will relate to the key engineering features for this project. Firstly, PLC. PLC is an industrial digital computer that's suitable to use in the automation process, which called a brain of the system. So this system, the PLC, we can control or we can determine the input to use and how the output will work. This PLC also reliable and very flexible to use in this project. Secondly, DC motor. for DC motor, it used to control speed of the motor. So DC motor will attach at the conveyor belt and it will control the speed of conveyor belt. So the relate with the key engineering features is the low speed and the flexibility. Thirdly, the component to use is proximity sensor, which a non-contact sensor that detects a presence of object within its range. So like told earlier, we use photoelectric sensor to detect an object, and also it will determine or will check the surface of the bottle. For the fourth component, which solenoid valve. So a solenoid valve is the mechanical device to activated when receive electrical signal. So basically solenoid valve is using in integrated inline system. So when the valve is turned on, it will flow the water or liquid inside the bottle for several seconds. Then after the bottle is fully, or after the water is at the full maximum place, the valve will close. Lastly, the component to use is weight sensor, which to measure the weight of the object. So basically it will place at the after manual packaging is done. So when the object is placed on the conveyor belt that have a weight sensor, it will measure the weight, and if achieve the condition, it will proceed to the next process. If not, it will stop at the operation, and we will move to the next part.
Assalamualaikum and hi, my name is Muhammad Hazim bin Kamarul Zaman, and I will present about result and discussion for our group. So for our group, because we only make a case study, so I gain some result from the internet that from previous student, maybe from the overseas student that make studies with the project that have same as we want to gain. So I got some of the result and graph from the journal I searched. So I will show you. So this is the result I gained from the Med journal. So this is their final construction prototype. As we seen, the filling machine is shown that if the button of the power supply is pressed, the conveyor motor will start to move. When the infrared sensor detect the bottle, the conveyor motor stop to move, and the DC pump will start to flow the water to fill the bottle. After completing the filling operation, the DC pump stops. For the first result I get is graph between time and solenoid valve opening. So from the graph shows that as the solenoid valve opening is increased, the time required to fill 200 ml liquid in bottle decreases. As the valve angle increases, the flow rate increases too. So for the filling different amount of liquid in the bottle, the filling time should be constant, but the flow rate will be different. For the second result, we gain that the graph between time versus the number of bottle. So from the graph shows that the graph pattern is directly proportional. So we can observe that as the number of bottle increases, the time required to fill 200 ml liquid in bottle increases too. To maintain the process time after increases the number of bottle, the solution we get is if the number of bottle increases, we should increase the quantity of machine, because it will equivalent the time that need to finish filling of bottle after have more than normal bottle. Right now, I want to present about discussion. I separate between two sections, which is the key features engineering, and the next one is the core challenge. So for the key engineering features, the automation lines, low speed design and flexibility have enabled the system to accommodate multiple type of products and bottle within a single day. The PLC-based control system allows for quick and efficient adjustment of machine parameters such as fill level, labeling requirement, and packaging specification. The integration of an inline filler within the automation line streamlines the bottle process, give crucial tasks of filling bottles. This feature ensured precious and efficient filling, minimizing product waste and maintaining consistent fill levels. The automated conveyance system, complemented by rapid rail adjustment, enhance transporting bottle between different stations. The ability to adjust the rail system quickly, facilitating changeover, reducing the downtime and enabling smooth transition between bottle size and product types. The next one is core challenge. So the identify core challenge including a restricted budget, handling various product type and bottle size, accommodating future bottle design, and ensuring quick changeover capabilities can be efficiently addressed through the integration of a PLC bottling automation line. The modular nature of PLC system allows for scalability and incremental implementation, facilitating cost-effective deployment within budgetary constraints. The flexibility of the PLC program and control enables seamless adaptation to handle diverse product types and size, even those that have not yet been designed. The quick changeover capabilities of the automation line will achieve through rapid rail adjustment, intuitive user interface, and automated parameter setting, minimize downtime and optimize product efficiency.
I will explain the last section of this project, which conclusion. So based on the finding from this proposed project, PLC is one of the way to automate the bottling line system. So this component is cost effective and can be replaced the wired relays in the operation. Besides that, we can reduce human labor energy in the operation. So with implementing the PLC also, we can synchronize with the key engineering features and also can overcome the core challenge of bottling line automation. With this new implementation, I can say that the number of bottles that fill up, or the number of bottles that completely fill, will increase for each day, and will lead to the increase of the competition of the factories. I think that's all for me and my friends. Thank you.